If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. Sharing it with your friends and family helps spread knowledge. And when we help others grow, we grow too. Thank you so much for listening. Let's dive into the podcast. The Enigma of the Cosmic Singularity. In 1931, a Belgian priest with a wild imagination changed everything. Georges Lemaitre sat in his study, watching numbers dance across pages of equations. What he saw made his hands shake. The universe was not eternal. It had a beginning. Lemaitre called it the primeval atom. Picture a single point, smaller than a grain of sand. Now imagine that this tiny speck contained everything. Every star, every galaxy, every breath of air you've ever taken. All of it pressed into one impossible dot. This wasn't just dense. This was infinitely dense. A place where the normal rules broke down completely. Einstein himself rejected the idea at first. Your calculations are correct, but your physics is abominable, he told the young priest. The great scientist couldn't accept that the cosmos had a birthday. It felt too much like creation itself. But the numbers didn't lie. The universe was expanding, racing away from some ancient starting point. If you played the movie backward, everything collapsed into Lemaitre's mysterious primeval atom. Scientists gathered in smoky conference rooms, arguing late into the night. What existed before this cosmic egg hatched? The question haunted them. Time itself might have begun at that moment. But how do you study something that happened before time existed? The primeval atom became a puzzle wrapped in riddles. Mathematical equations described it perfectly, yet no one could explain what it really meant. Was it the beginning of everything, or just the limit of human understanding? Some researchers whispered about the philosophical implications. If the universe had a definite starting point, did that mean it was created? The boundary between science and theology began to blur in uncomfortable ways. Other physicists tried different approaches. They searched for loopholes, alternative theories, anything to avoid the troubling implications of the primeval atom. Yet the evidence kept pointing back to that singular moment when everything began. The singularity, as it came to be known, marked the edge of the knowable world. Beyond it lay terra incognita. Here, the tools of science seemed to fail. Temperatures became infinite. Density became infinite. The very fabric of space and time twisted into impossible shapes. What made it even stranger was how this cosmic mystery connected to black holes. These dark objects in space also contain singularities at their centers. The same mathematical breakdown that described the beginning of everything also lurked inside these stellar graveyards. Lemaitre's primeval atom had opened a door that couldn't be closed. It revealed that the universe contained fundamental mysteries that might never be solved. The beginning of everything remained tantalizingly out of reach, a secret locked away in the first moments of cosmic time. The Clash of Origins, Big Bang versus Steady State. The year was 1965, and two scientists were about to stumble upon something that would shake the very foundations of what we thought we knew about our universe. Arno Penzias and Robert Wilson were trying to fix what they believed was a persistent problem with their radio antenna. No matter what they did, a strange hiss kept coming through their equipment. They cleaned pigeon droppings from the antenna. They checked every wire and connection. Still, the mysterious signal remained. It was faint but constant, coming from every direction in the sky. The two men had no idea they were listening to the whispered echoes of creation itself. Meanwhile, across the scientific world, a fierce battle was raging between two camps of brilliant minds. On one side stood Fred Hoyle, the sharp-tongued British astronomer who believed the universe had always existed in what he called a steady state. Stars died, new ones formed, but the cosmos remained essentially unchanged throughout eternity. On the other side were scientists who supported a radical idea that Hoyle mockingly called the Big Bang. They believed everything began in a single explosive moment roughly 14 billion years ago. The universe started smaller than a pinhead and expanded outward, cooling as it grew. Both sides had weapons in their scientific arsenal. Hoyle pointed to the smooth distribution of galaxies and the continuous creation of matter. His opponents countered with Edwin Hubble's startling discovery that distant galaxies were racing away from us, as if fleeing some ancient explosion. Then came that persistent hiss that Penzias and Wilson couldn't explain. Word spread quickly through the scientific community. Could this background radiation be the afterglow of the Big Bang itself? The temperature matched predictions perfectly. If the universe had indeed begun in a fireball, this faint warmth should still be detectable everywhere. The discovery hit Hoyle's steady-state theory like a hammer blow. Here was physical evidence of a cosmic beginning, written in radio waves across the entire sky. The universe wasn't eternal and unchanging. It had a birthday. Yet questions lingered in the shadows. What came before that first moment? How could something emerge from nothing? The cosmic microwave background answered one mystery, but opened doors to countless others, each more puzzling than the last. Inflation and the edge of knowledge. Picture this. A young physicist sits in his office in 1980, staring at equations that refuse to make sense. Alan Guth had stumbled upon something extraordinary. The universe, he realized, might have grown faster than anyone ever imagined. What if everything we see today started smaller than a grain of sand? What if it then exploded outward at impossible speed? This wasn't the Big Bang itself. This was something that happened right after it. Guth called it inflation. The idea sounds crazy at first. In less than a trillionth of a second, space itself stretched so fast that a tiny speck became larger than a basketball. Nothing moved through space at this speed. Space itself was expanding. But here's the strange part. This wild theory actually explains things that puzzle scientists. Why does the universe look the same in every direction? Why is the temperature so even across the vast cosmos? Inflation gives us answers. Think of a balloon with wrinkles on its surface. Blow it up fast enough, and those wrinkles disappear. The surface becomes smooth and uniform. That's what happened to our universe during inflation. Any bumps or differences got stretched away. Scientists found proof hiding in ancient light. When they looked at the oldest radiation in space, they saw tiny patterns. These patterns matched exactly what inflation predicted. The COBE satellites saw them first. Later, WMAP confirmed the discovery. Yet solving old puzzles created new ones. If inflation happened, what came before it? What caused this incredible expansion to start? And more troubling, what made it stop? Some scientists argue we can never know what happened before inflation. The expansion erased all traces of earlier times. Others push back. They believe clues must exist somewhere. The math gets stranger the deeper we look. If inflation happened once, it might happen again. Perhaps it's happening right now in distant parts of space we can't see. This creates infinite universes, each with different laws of physics. Stephen Hawking once said that asking what came before the Big Bang was like asking what lies north of the North Pole. But inflation theory suggests the question makes perfect sense. Something had to trigger this cosmic growth spurt. Today's telescopes keep finding evidence that supports inflation. The patterns in space radiation grow clearer with each observation. Yet the biggest questions remain unanswered. Scientists stand at the edge of knowledge, peering into a mystery that grows deeper with each discovery. Inflation explains our universe perfectly, but it also opens doors to stranger possibilities than anyone imagined. What lies beyond that first moment of incredible expansion continues to haunt the greatest minds in physics. Bouncing universes and the black hole conspiracy. The numbers whispered something different. Dr. Elena Vasquez stared at her computer screen, watching gravitational wave data pulse in strange patterns. The signals from deep space told a story that made her hands shake. What if the Big Bang wasn't the beginning at all? For decades, scientists accepted one truth. Our universe started from nothing in a massive explosion. But hidden in classified research papers and forgotten calculations, other ideas waited in the shadows. Elena discovered something that changed everything. The gravitational waves showed ripples that shouldn't exist. They came from before the supposed beginning. The data suggested our universe might bounce like a rubber ball, dying and being reborn forever. She wasn't alone in her discovery. Around the world, quiet groups of scientists whispered about similar findings. They called them bouncing universes. Each death led to a new birth. Each collapse sparked a fresh explosion. But the mystery went deeper. Late one night, Elena received an encrypted message from a physicist in Tokyo. He claimed our entire universe might exist inside a massive black hole from another dimension. The mathematics worked perfectly. Too perfectly. The evidence kept growing. Dark matter behaved in ways that suggested memory from a previous cosmic era. Quantum calculations showed time might loop backward and forward like a twisted ribbon. Space itself carried scars from universes that came before. Government agencies began asking questions about Elena's research. Phone calls came at odd hours. Funding disappeared without explanation. She realized something important was being hidden from the public. Loop quantum gravity researchers published papers in obscure journals. They spoke in code about cyclic time and infinite universes. Their work suggested reality operated like a vast machine, creating universe after universe in an endless chain. Elena met with other scientists in secret locations. Coffee shops, empty parking lots. They shared data that major universities refused to acknowledge. The evidence pointed to something incredible and terrifying. Our universe wasn't unique. We lived in one bubble among millions. Each bubble contained entire galaxies and civilizations. When one bubble collapsed into a black hole, it gave birth to another universe inside itself. The conspiracy of silence grew stronger. Research grants went to safe projects. Bold theories disappeared from mainstream conferences. But the truth couldn't stay buried forever. Elena published her findings online, bypassing traditional journals. Within hours, the article vanished from servers worldwide. Someone didn't want this information public. The questions haunted her sleep. How many universes came before ours? What secrets did they leave behind? And why did powerful forces work so hard to keep these mysteries hidden? The answers waited in the darkness between stars. The unsolved riddle, laws, limits, and cosmic secrets. Picture this. Every time scientists think they're close to answering the ultimate question, the universe seems to laugh at them. The harder they push, the more mysterious everything becomes. Take the singularity, that impossible point where our universe supposedly began. Here's where things get strange. All the laws of physics we trust simply break down. Temperature becomes infinite. Density becomes infinite. Time itself stops making sense. It's like trying to divide by zero on a cosmic calculator. The math just screams error in bright red letters. Scientists have spent decades building machines that smash particles together at incredible speeds. They've created conditions hotter than the center of stars. Yet every experiment only pushes the mystery further back in time. They can see what happened a tiny fraction of a second after the Big Bang. But that crucial moment before, it remains hidden. The problem runs deeper than missing equipment. Our best theories about gravity don't play nice with quantum mechanics. Einstein's equations work beautifully for big things like planets and stars. Quantum rules govern the tiny world of atoms and particles. But at the moment of creation, big and small crash together in ways we can't understand. Then there's time itself. We all know time moves forward. We age, milk spoils, ice melts. But why? The deepest laws of physics don't actually care which direction time flows. Yet something about the beginning of everything created this arrow of time. What forced the universe to choose a direction? Recent experiments using the most powerful telescopes have pushed our view further back than ever before. We can now see light from when the universe was just 380,000 years old. But this only makes the mystery more intense. The patterns we observe suggest something happened before the Big Bang. Yet we have no way to reach back and touch it. Each new discovery brings more questions. Dark matter that we can't see but know must exist. Dark energy pushing space apart faster and faster. These aren't small problems. They make up 95% of everything that exists. If we don't understand the present universe, how can we hope to grasp its beginning? The strangest part? Some physicists now suspect the question itself might be wrong. Maybe asking what came before is like asking what's north of the North Pole. Perhaps our human need for beginnings and endings doesn't match how reality actually works. And so the mystery persists. In laboratories around the world, brilliant minds continue their search. Each calculation, each experiment, each late-night discussion brings them face to face with the same profound silence. The universe keeps its deepest secret locked away, leaving us to wonder about the shadows that dance just beyond the edge of creation.